Next topic is the mechanical advantage. Now we have already deal with this term in the subject of engineering mechanics. If you remember, there we find out the mechanical advantage of the screw jack. And what actually was mechanical advantage? This mechanical advantage is equal to total load lifted, ratio of total load lifted to effort applied. Okay, and as the name suggests, how much advantage we are getting mechanically. Mechanically means how much force we are applying and how much load we can lift against that particular force. That is nothing but mechanical advantage, and this mechanical advantage has to be greater than 1. That means the load which has to be lifted obviously has to be greater than that of the effort applied, then only that particular device can be useful. Okay, so this is nothing but the mechanical advantage, and this, or you can also call it as, this is nothing but force output. Okay, load lifted, you can call it as force output divided by force input. Okay, so this is actually the ratio of output to input. Getting this now? Okay, if you remember one more term, that was efficiency. That efficiency was also the ratio of output to input. Okay, efficiency को भी हमने कैसे define किया था? It was also output to input, but this efficiency was always less than 1. Getting this? And this mechanical advantage is always greater than 1. So what actually is the difference between these two? Efficiency में और mechanical advantage में आखिर difference क्या है? क्योंकि दोनों को हमने वैसे ही डिफाइन किया, आउटपुट अपॉन इनपुट. सो जस्ट अंडरस्टैंड दिस थिंग, दैट मैकेनिकल एडवांटेज इज एक्चुअली फोर्स आउटपुट टू फोर्स इनपुट. That means how much force we are applying at input and how much force we are getting at output. That is mechanical advantage. Efficiency is actually the power output. Efficiency को हमने कैसे डिफाइन किया था? Total work done divided by heat input. Work output divided by heat input. This was efficiency. Okay, or you can say, you can also call it as power output divided by power input, or energy output divided by energy input. Getting this or not? So efficiency is actually energy output to energy input or power output to power input. Mechanical advantage is actually force output to force input. Okay, power cannot be magnified. Power जो है, whatever input power we are supplying, maximum case में वो 100% power हमको output में मिल सकता है, but it cannot be magnified, can never be magnified. ओके और उसके बाद हो सकता है कि वो पावर डिक्रीज भी हो जाए, तो इसलिए हम उसमें एफिशिएंसी निकालते हैं कि हाउ मच परसेंट ऑफ दैट पावर और दैट पर्टिकुलर एनर्जी विच वी आर गिविंग इट एज इनपुट, हाउ मच परसेंट ऑफ दैट एनर्जी इज एक्चुअली यूटिलाइज्ड एज आउटपुट एंड रेस्ट ऑफ द एनर्जी इज वेस्टेड. तो उसका रेशियो, उसी को हम क्या बोलते हैं? एफिशिएंसी. गेटिंग दिस नॉट? और पावर क्या होता है? दिस पावर कैन बी रिटन एज दिस, कैन बी इक्वल टू फोर्स इंटू वेलोसिटी, और इन टर्म्स ऑफ टॉर्क इंटू एंगुलर वेलोसिटी, ये बोल सकते हैं हम पावर को. ओके, तो यहीं से इसका डिफरेंस क्लियर हो रहा है. दिस पावर कैन नॉट बी मैग्नीफाइड, दिस पावर कैन नॉट बी मैग्नीफाइड एट ideal condition. This power will remain constant, but this torque or this force can be magnified. How? If I am increasing the force, this velocity will decrease. If I am decreasing the force, this velocity will increase. Similarly, if I am increasing the torque, the angular velocity will decrease, and if I am decreasing the torque, the angular velocity will increase. Getting this now? So we can easily magnify this torque or this particular force, okay, but we cannot magnify this power. Getting this or not? Okay, so what we can write this mechanical advantage as I told you, force output, the ratio of force output to force input, force output to force input, and this can also be equal to torque output, the ratio of torque output to torque input. This is nothing but mechanical advantage, the ratio of torque output to torque input. Okay, now efficiency, as I told you, is equal to power output, the ratio of power output to power input. Okay, now this can be written as T into omega at output divided by T into omega at input, the ratio of T into omega at output to T into omega at input. Now what is this T output to T input? This T output to T input, the ratio of this T output to T input can be written as mechanical advantage. So this will be equal to mechanical advantage into omega output upon omega input. Getting this now? Okay, so from here you can find out the value of this mechanical advantage in terms of omega, So this mechanical advantage will be equal to efficiency into omega input to omega output. Getting this now? Okay, now if this efficiency is 100%, if efficiency is 100%, that means 100% of power is getting transmitted. If efficiency is 100%, then obviously this mechanical advantage will be equal to omega I upon omega naught. So in terms of angular velocity, mechanical advantage is omega input to omega output, and in terms of torque, and this is the case in only in case in which the efficiency is 100%, and in case of torque this mechanical advantage is equal to torque output to torque input. Getting okay this? So next topic is the transmission angle. Now what actually is this transmission angle? This transmission angle is the angle between this coupling rod and between output. Okay, the angle between connecting rod or coupling rod and output is nothing but the transmission angle, which we denote by gamma. So this gamma is nothing but transmission angle. Getting this or not? Okay. Now what should be the ideal value of this gamma? Now just understand this thing very carefully, students, that this particular link CD, we are considering this as crank and rocker mechanism. This is crank rocker mechanism. That means the shortest link is adjacent to fixed link. Okay, we are considering the shortest link as adjacent to fixed link, and let's suppose this L plus S is less than or equal to less than P plus Q, and the shortest link is adjacent to fixed link. So obviously the mechanism which we will be getting is the crank rocker mechanism. Okay, so in this crank rocker mechanism, this link CD is reciprocating about this point D. Okay, ये इस तरीके से reciprocate हो रहा है. Getting this? That means अगर मैं यहाँ का point C का अगर मैं velocity vector बनाना चाहूँ, that velocity vector would be perpendicular to this link CD. Yes or no? Okay, in further lecture of velocity analysis we will understand this, क्यों इसके perpendicular होता है. But I think basic idea आपको होगी कि अगर link किसी point के about rotate कर रहा है तो उसका जो velocity vector रहेगा that would be perpendicular to that particular link. So this CP is actually perpendicular to CD. This is perpendicular. Getting this or not? Okay, तो velocity इसकी है along CP. Okay, but जो power transmission हो रहा है that is along BC. Okay, BC के through power transmission हो रहा है, but the velocity, ideally velocity कहाँ पर आ रही है? Along CP. Okay, so there is a gap between these two. Getting this or not? And because of that, an unwanted, unnecessary pressure will be created in this particular mechanism, and that's why the angle, this particular angle, okay, this angle is, let's suppose, phi. So this angle phi is known as pressure angle. Getting this not? Okay, I will explain you again. This particular link CD is reciprocating about point D. That means the velocity vector should be CP, along CP. Okay, ideally what should happen, if the force is getting transmitted along this velocity vector, then it would have been the ideal condition. The loss would be minimum. Okay, but the force is getting transmitted along this BC और velocity vector है हमारा along CP. That means एक unnecessary pressure इस particular mechanism में create होगा, and the angle between this CP and CB is nothing but the pressure angle. Clear or not? Okay. Now the question arises, what should be the ideal value of this gamma? So I told you what should be the ideal value of this gamma. Okay, for ideal power transmission, this gamma obviously should be equal to 90 degree. Okay, ये 90 degree है अगर ये gamma, then the power transmission you can consider it as ideal. But every time it cannot be 90 degree. Okay, because this link is continuously rotating and this is reciprocating, this is reciprocating, then obviously there has to be some change in angle between them. Okay, so if this gamma is actually 90 plus minus of 30, this is based on the experience. If the angle between these two links between BC and CD lies between 90 plus minus 30, 90 plus minus 30 means it lies between 60 to 120 degree. So if this angle is lying between 60 to 120 degree, then you can consider it as an ideal mechanism. And this angle, actually this transmission angle gamma is actually decides the quality of the mechanism. Okay, what quality, किस quality का mechanism है वो decide करता है ये gamma. Okay, if this gamma is lying between 90 plus minus 30 की अगर range में ये gamma lie करता है, then you can call it as good mechanism, effective mechanism. Otherwise it is not so effective mechanism. Now let's suppose the lengths of this links are given. Let's suppose the length of this fixed link is A, length of this shortest link is, let's suppose, B, this is length is C, and this length is, let's suppose, D, and this length is, let's suppose, H. Getting this or not? Okay, now in this triangle, in triangle ABD, okay, what you can write as A square plus B square minus 2AB cos of theta, this should be equal to H square. ओके, ये कोसाइन रूल से हम क्या लिख सकते हैं, एच स्क्वायर इज इक्वल टू ए स्क्वायर प्लस बी स्क्वायर माइनस 2ab cos of theta. Getting this? Similarly, in this particular triangle, in triangle BCD, again this h square can be written as what? C square plus d square minus 2 CD cos of theta. This is also equal to h square. Let's suppose this equation is 1 and this is, let's suppose, equation number 2. Okay. Now equating these two equation, equating 1 and 2, what we will get is a square plus b square minus 2ab cos theta. This should be equal to c square plus d square minus 2 CD cos of theta. Getting this? Okay. Now differentiating this particular equation, okay, if I am differentiating this with respect to theta, I am differentiating this with respect to theta, what I will get? So this term will become 0, this will be 0 plus 0 plus, okay. Now this is minus 2ab cos theta, differentiation of cos theta is minus sin theta, so this will be minus minus plus 2ab sin of theta, okay. This should be equal to again 0 plus 0, okay. This will be minus CD cos of, sorry, this angle will be gamma, not theta, this angle will be gamma, okay. C square plus d square, h square is equal to c square plus d square minus 2 CD cos of gamma, okay. C और d के बीच का angle है, okay. So this angle should be gamma, not theta. Getting this or not? Okay. So this will be equal to 0 plus 0 minus minus plus 2 CD, okay, cos gamma sin gamma, okay, into d gamma by d theta. Getting this one? Okay, so from here we will get what? This d gamma by d theta. Okay, what will be the value of this d gamma by d theta? This will be equal to a into b sin of theta divided by c into d sin of gamma. Getting this one? Okay. Now for this particular expression, for this for the value of this gamma to be minimum and maximum, हमको क्या करना था? गामा की वैल्यू मिनिमम मैक्सिमम के लिए थीटा का एंगल फाइंड आउट करना था. ओके, सो फॉर दिस गामा टू बी मैक्सिमम और मिनिमम, दिस डी गामा बाय डी थीटा शुड बी इक्वल टू 0. This should be equal to 0. Getting this not? Okay. Now for this particular condition, obviously this a into b sin theta should be equal to 0. Now this a and b are the length of the link length, so this cannot be equal to 0. So this sin theta should be equal to 0. Getting this? And if sin theta is equal to 0, then obviously this theta should be equal to 0, then pi, then 2 pi, then 3 pi, and so on. Okay, so for maximum and minimum value of this gamma, this theta should be equal to 0, pi, 2 pi, 3 pi, and so on. Okay, and for gamma minimum, this theta should be equal to 0, then 2 pi, then 4 pi, and so on. And for gamma maximum, this theta should be equal to pi, 3 pi, 5 pi, and so on. Okay, अब ये कैसा होगा? Okay, so for minimum value of gamma, और ये यहीं से फिगर से ही समझ में आ जाएगा, कोई ये रॉकेट साइंस नहीं है. ओके, मिनिमम वैल्यू ऑफ गामा के लिए क्या होगा? फॉर गामा टू बी मिनिमम, ओके, दिस लिंक ए बी शुड कोइंसाइड विथ ए डी. ओके, जब ये लिंक ए बी घूम के यहाँ पर आएगी, डेट मीन्स इफ द एंगल ऑफ दिस, इफ दिस थीटा इज 0 डिग्री, ओके, देन ऑब्वियसली दिस गामा विल बी मिनिमम. Getting this or not? And the mechanism we will get like this. ये जो mechanism मिलेगा हमको, it will be like this. This is point A, this is point B, okay. Then this is link BC, this is point D, and this is nothing but gamma minimum. Getting this or not? Okay, so this is the condition when gamma is minimum. Okay, when theta is equal to 0 degree, जब 0 में होगा, then उसके बाद 2 pi पे होगा 360 degree, then 4 pi, then 6 pi, and so on. Similarly, gamma maximum कब होगा? When this link is at this particular point. Okay, that means if theta is equal to pi, theta is equal to 180 degree. Okay, then this is link AB. This will be point B. Okay, then this is point C, and then point D. Okay, so this should be nothing but gamma maximum. Getting this? तो ये जो एंगल है, this angle is nothing but pi. Clear or not? Here this angle is nothing but 0 degree. Okay, so for theta is equal to pi, 3 pi, 5 pi, 7 pi, हमको गामा मैक्सिमम मिलेगा. For theta is equal to 0, 2 pi, 4 pi, and so on, we will get gamma as minimum. Clear or not? Okay, now we will solve one question for this particular transmission angle. Okay, so now we will solve this question. In this particular configuration, we have to find the maximum and minimum value of transmission angle. angle, this angle gamma, maximum and minimum value of this angle in this particular configuration. Now how can we find out this thing? So let's suppose the link lengths are already given. The link length of AD is 3 centimeter, AB is 1 centimeter, BC is 3 centimeter and CD is 2 centimeter. Getting this on? Let's suppose I am naming this as, let's suppose this is A, this is B, this is C and this is, let's suppose, D. Getting this on? So for maximum and minimum value of transmission angle, let us first draw the configuration कि maximum value of transmission angle में कैसा configuration हमको मिलेगा and minimum value of transmission angle में किस तरह से configuration मिलेगा. So this is A, B, C and D. Okay, this is gamma minimum. Okay, this is the configuration for minimum value of transmission angle. Okay, this whole length is A, this whole length is A. Okay, and this length AB is B. Okay, this is C and this is D. This is for gamma minimum. Getting this? Similarly, gamma maximum के लिए क्या होगा? So for gamma maximum, this point is A, this is D, this is B, this is C. Okay, so this is for gamma maximum, and this values, this length is A, this is B, this is C, and this is D. Getting this now? Okay, so for this minimum and maximum value of gamma, for this we have to find out the minimum and minimum value and maximum value of gamma. Now how can we find simple cosine rule? Okay, so for this particular triangle we can apply this cosine rule. This distance BD square is equal to BC square plus CD square minus 2 BC CD cos of gamma minimum. Getting this or not? Okay, so this BD square, what is this BD square? This is nothing but A minus B. A minus B is nothing but BD. So this is A minus B whole square is equal to C square plus D square minus 2CD cos of gamma minimum. Getting this? Now we have got the value of A की value है हमारे पास, B की value है, C की value है, D की value है. Only unknown here is gamma minimum. You can just put the value, you will get the value of this gamma minimum, and this gamma minimum will be equal to 41.4 degree. Simple thing. Getting this? Similarly, for this particular figure, again we can use the cosine law as A plus B whole square. This A plus B whole square is equal to C square plus D square minus 2CD cos of gamma max. That's it. Same thing. We have the value of A, B, C and D. From here we can determine the value of this gamma max, and this gamma max from here is equal to 104.5 degree. So very simple question. Okay. So इस तरह के क्वेश्चंस ट्रांसमिशन एंगल से हमको आ सकते हैं. क्लियर और नॉट? ओके.